So in this video, I'm going to do a few examples of optimization problems. So the process of optimization, remember, is finding a maximum or a minimum. And to do that, we find our function and then we take the first derivative and set it equal to 0 to find the critical points. And then we determine if our critical point is a max or a min. And it's kind of based on the context of the problem if we want the max or the min. The hardest part of these problems is they're not just going to come out and give you the function. They're going to give you a situation and you have to come up with the function that you're trying to maximize or minimize. So that's going to be the hardest part of these problems. So I'm going to do a few examples. They usually come into like two main types, and I'll show both of those types. So this is example 6 on the packet. It's on page 20 of the packet. And this question says that a larger retailer selling mountain bikes has found that for every 20 reduction in price, so this should really be a 0 instead of an O, 2 more bikes are sold per month. The bike usually sells for $9.50, and at that price, the store sells 50 bikes per month. Find the optimum price to charge in order to maximize revenue. How many bikes are sold at that price? What is the maximum revenue? Okay, so the whole idea is we need to maximize revenue. So we need a formula for revenue. Now, remember, revenue is equal to X times P, where X is the number of units sold and P is the demand function. So we, or I guess P of X, need the demand function and we need X. So in this case, the units sold are bikes. So X is going to be the number of bikes sold. And then we need a demand function, P of X. Now, our demand function is going to be, in this case, linear, because when they describe the situation, they're saying as the price goes down by a fixed number 20, the bikes sold goes up by a fixed number 2. And so what that means is that we have a linear slope, we have a linear function because the slope is constant. It's always that the price is going down by 20 and the bikes are going up by 2. And so when we do our P function, it's going to be a line. So it's going to be in that format mx plus b. So we're just using P instead of Y. If you're more comfortable with Y, you can, it doesn't matter. But just remember, like, P is my price of a bike. Now I'm going to use the information to come up with 2 points so that I can find the slope and I can find my y-intercept, which is the 2 things I need for a line. So I know that when I have 50 bikes, the price is $9.50. Now we want our function in terms of X. So my X value is the number of bikes sold. So that's going to be 50. And my Y value is the price. So they also told me that every 20 reduction in price, 2 more bikes are sold. So what I'm going to do is I'm going to add 2 to 50 because 2 more bikes would be sold. So it'd be 52. And I would subtract 20 from my price. So I would get 930. And that would give me my new point for my X and my Y, or X and P in this case. So from these points, I can find the slope. So remember, the slope, we subtract the Y values. So I'm going to do 930 minus 950 over 52 minus 50. So I get negative 20 over 2, which is negative 10. And that makes sense because we said my price is going down by 20 and my bikes are going up by 2. So the rise should be negative 20 and the run should be 2. And that gives me negative 10. So you can also just put that as your slope. That's how they do it in the answer key. But if you're not sure about like how to get that, you can write out the points and then use the slope formula. So I'm going to plug that negative 10 in for my M, and then I have to find B. I can use either point, so I'll just use the 50, 950. My P is 950. my X is 50, and then I'm going to use this to find B. So negative 10 times 50 is negative 500. And then I would add 500 to both sides to get B. And this gives me 1450. Okay, so my price function is negative 10x plus 1450. And then my revenue, R of X, is going to be X times this function. Okay, please make sure you label R and P like you need the left-hand side of the equation. You can't leave those out. So because I want to take the derivative and I don't want to deal with product rule, I'm just going to distribute the X right away. So I get negative 10x squared plus 450x. If I do that, I don't have to use product rule. So this is my revenue function. Because I am trying to look for the max, I am going to take the first derivative and set it equal to 0 to find the critical point. So this is negative 20x plus 450. I'm going to set that equal to 0. So I would subtract 450 from both sides, and I'd get negative 20x equals negative 450. I would divide by negative 20. Oh, sorry. Hold on, go back. I changed my 1450 to a 450. So this should be 1450, 1450, sorry, 14, 14, 14. Okay, so I'm just changing all of my 450s to negative 1450 because I rewrote my problem wrong from the one step. So I'm going to do negative 1450 divided by negative 20. Okay, so I get 72.5. Now, we're talking about bikes, and it doesn't make sense to have half a bike, so we'll always round up with these. So I have approximately 73 bikes. Okay. But the max, or we need to check that it's a max, but most likely the max is occurring here. The easiest way for these, if it's a function that's like easy to take the derivative, to check that it's a max is to take the second derivative. So if I come back to my derivative and I take the second derivative, it would just be negative 20. And so if you get the second derivative negative, what that means is my function is concave down. And the critical point, remember, is where the derivative is 0. So it's a max or a min. And so because it's concave down, at my critical point of 72.5, I would have a max. So you should always show whether you get a max or a min. You need to verify it. So you should take the second derivative. If it's concave down, you have a max. If it's concave up, you have a min. And that's enough information to check that it's a max. So we found the number of bikes that we need to be a max. But it also asked, so we found how many bikes are sold, but it says find the optimum price, and it says what is the maximum revenue. So I need to find two things. I need to find P and I need to find R. Okay, so we have our R function right here. So I'll just do that now. I'll plug in 73 into my revenue function. So this negative 10x squared plus the 1450 times x, and I'm going to find that value to get my revenue when I sell 73 bikes. So if you do that, you would get and this is in dollars, $52,560. So that would be the revenue for selling 73 bikes. I also want the price per bike. So I'm going to use my P of X formula, my P formula, and plug in the 73 again. So P was negative 10X plus the 1450. And I would plug in negative 73. And I'm going to use the 73 because that's the number of bikes we're saying we're selling instead of the 72.5. And that gives me 720. So the price of the bikes that they're selling now is $720. So just make sure you answer all parts of the question. So just to go back, they asked us for the optimum price, which is what we just found, how many bikes are sold, which was the 73, and the maximum revenue, which we found to be the 52,560. So then the next example I'm going to do is number 2 from the packet, which is on page 21. And this is kind of the second way you could set up these problems. So this one says a strawberry farmer will receive $4 per bushel during the first week of harvesting. Each week after that, the value will drop by 10 cents per bushel. The farmer estimates that there are approximately 120 bushels in the field, and the crop is increasing at a rate of 4 bushels per week. When should the farmer harvest the strawberries to maximize their value? How many bushels will yield the maximum value? And what is the maximum value of the strawberries? Okay, so the main thing we're trying to do is we're trying to maximize our value of the strawberries. So we need an equation for that. And when we talk about the value, we're looking at our revenue. Again, we're trying to maximize the total amount we get from selling the strawberries, which would be our revenue, our R of X. And in this case, our revenue is going to be however many baskets we sell of strawberries times the price per basket. Okay, or bushels per is what we're selling it. So how we would find the revenue is we would take the number of bushels that we sell and we would multiply it by the price per bushel, because that's what they're telling me in this problem. Okay, so they're telling me, like, for example, they'll receive $4 per bushel during the first week of harvesting. Each week after that, the value drops by 10% per bushel. So what we're really trying to figure out is what week we need to sell them. So our X is going to be the number of weeks after the first week. Okay, so actually our first week would then X would be 0 because that's 0 weeks after the first week. And that second week would then be X is 1. Just keep that in mind. So when we write the revenue formula from this, we can just kind of write exactly what they described in here. So they told me that we'll receive $4 per bushel during the first week of harvesting. Each week after that, the value will drop 10 cents per bushel. And then it says the farmer estimates that there are approximately 120 bushels in the field, and the crop is increasing at a rate of 4 bushels per week. Okay, so if we focus on the number of bushels, we're starting with 120 bushels. So I'm going to have 120. And then it says it's increasing at a rate of 4 bushels per week. So I would do plus 4 times X, because again, X is the number of weeks after our first week. So the first week, our X is 0, so we would just get 120. A week after that, X would be 1, and we would end up with 124. So this is how we get this expression. For the price per bushel, okay, we know that the price starts at $4 a bushel. And each week after that, the value is going to drop by 10%. So what we would do is we'd have to subtract 10% times the number of weeks it is, because it's 10% per week. So it'd be 0.10 times X, the number of weeks. And that would be decreasing my bushel price by 10% each week. So this gives me the price per bushel. This gives me the number of bushels. These two multiplied together gives me R of X. Now it's up to you if you want to do product rule or if you want to multiply this out first and then take the derivative. I'm going to multiply it out first because we're going to have to find the first and the second derivative to verify it's a max. So it's easier to do the per hour rule than a bunch of product rules. So I'm going to use FOIL when I multiply this out. So I get 120 times 4, which is 480. Then I have 120 times a negative 0.10, which is minus 12x. Then I have 4x times 4, which is 16x. And I have 4 times negative 0.10, which is a negative 0.4 x squared. Combining my like terms, I get 480 plus 4x minus 0.4x squared. That's my revenue function. Okay, then I can take the derivative. 480 is 0, 4x is 4, minus 0.4x squared is minus 0.8x. I'm going to set this equal to 0. So whenever we're trying to find the max or min, we take the first derivative, we set it equal to 0. So I get 4 equals 0.8x. I'm going to do 4 divided by 0.8. And I get x is equal to 5. Okay, so that means it's number of weeks after the first week. It's 5 weeks after the first week. So we're really looking at the 6th week of harvesting. So let's look at the questions. When should the farmer harvest the strawberries to maximize their value? Okay, so we would say he wants to harvest 5 weeks after the first week. Okay, now before I do that, one thing we need to make sure is that we are getting a maximum. So to do that, I'm going to take the second derivative. So here's my first derivative. The second derivative, 4 is 0. Negative 0.8x is negative 0.8. Okay, so it's negative, which means it's concave down. And I do have a max. So again, don't forget to check that part. So I am going to harvest 5 weeks after the first week. Okay, so the farmer should harvest or the 6th week, if you want to put it that way, it doesn't matter. And then we need to answer the other question. So how many bushels will yield the max, and what is the maximum value of the strawberries? Okay, so our revenue is the maximum value of our strawberries. It's how much we're selling our total for. So to do that, we would find R of 5. So I'm going to plug in 5 into my original function. I'm going to use my simplified function because it'll be a little bit easier. So 4 times 5 minus 0.4 times 5 squared. I'm just going to type that into my calculator. And I get 490. Okay, that's the maximum value of the strawberries. And then the last part, how many bushels will yield the maximum value? Okay, so remember, number of bushels is this part of the formula, 120 plus 4x. So I'm going to plug it into that. Okay, so let's just say B for number of bushels is that 120 plus 4x. So I'd have B equals 120 plus 4 times 5. Okay, and that gives me 140. So there's 140 bushels. Okay. So 140 bushels will yield the maximum value. And that answers all the questions that they asked. So we found the maximum price of the strawberries, the number of bushels, and then also how many weeks after the first week. So those are two different optimization problems and kind of the two different ways you set them up. And in a few other videos, I'll do a few more examples. Just let me know if you have any questions.